Okay, guys. So today we're moving on to chapter 6, and today we're going to be talking about solving systems by graphing. In order to solve a system by graphing, we have to know what a system is. A system of equations is a set of two or more equations. Any equations. They can be linear, quadratic, cubic, absolute value. Doesn't matter. A system of equations is just a set of two or more equations, period. And it's used when you have two or more related unknowns. Now, we're going to talk about a specific system called linear systems. And a linear system consists of two or more linear equations. A solution of a system is a value or set of values, remember the ordered pairs, x comma y, for the variable that makes all the equations true. So basically, the solution of the system is an ordered pair that when plugged into both original equations will make both original equations a true statement. The solution of a linear system is the intersection point of the given linear equations. So when we are solving a system by graphing, gentlemen, it's very simple. A, first step, solve both equations for y. If they're not already solved for y, you must solve them both for y. You've got to put them into y equals mx plus b form. Step 2, graph each of them individually. Okay? I already have them graphed here, but let's go ahead and show you how I got this. Let's make this equation 1 in red. Let's graph that bad boy. Y-intercept is 5. My slope is 2/3, so that means I went up 2 over 3. Let's go backwards, down 2 over 3, down 2 over 3, and then I can connect the dots. Very simple. Let's go ahead and make equation 2 in blue. My y-intercept here is 1. My slope is negative 2/3, down 2 over 3, down 2 over 3. But if I keep going to the right, I will never intersect with this red line. So I got to go backwards. Up 2 over 3 going backwards. Up 2 over 3 going backwards. So this bad boy be right there. Okay? And actually, that looks ugly. Should be right there. So it's right there. And where do they intersect? They intersect at this green point, which is negative 3, comma 3. That is the solution. Yes, sir. Okay, the question was, do we have to color in each equation different colors? No, sir. I'm just doing that for visual appearance right now so you can really see what's going on. Now, when you have your solution here, guys, you can check to make sure that you got this solution correctly. Plug it in. Plug it back in to each equation, and it better be true. So for equation 1, we've got y equals 2/3 x plus 5. So let's plug in the x and the y and see if it's true. Y is 3. Will that equal 2/3 times x, which is negative 3, plus 5? This is 3 equals negative 2 plus 5. So 3 does equal 3. So negative 3 works. We're good. Let's test it now for the second equation. Y, which is 3, must equal negative 2/3 times x, which is negative 3, plus 1. Well, this is 3 equals, that's 6 divided by 3, so that's 2 plus 1, and 3 does equal 3. So both of them work. Both equations are solved by that one solution. So we graph them, see where they intersect, plug those points in to make sure we got them correct. Does that make sense? Okay, so let's see what we do. Find the solution to the system by graphing. Always do it this way, my friends. I suggest strongly. 1 and 2. No, you do not have to have different colors. I am just showing you different colors because I am teaching it. So for equation number 1, we've got negative 3x plus 2y equals 8. All right, I got to solve for y. So I'm going to Add 3x to both sides. Very good. So I got 2y equals 3x plus 8. I'm going to solve for y by dividing by 2. Awesome. Divide by 2. So y equals 3 halves x plus 4. Please remember, I'm still having gentlemen tell me that this is 6x equals 16. 6x plus 16. This is a division that divides to that and divides to that. 3 divided by 2 is 1.5. We do not write slopes in decimal form. We write slopes in fraction and only fraction form or improper fraction, but never as a mixed number, never as a decimal, so you leave that 3 over 2. 8 divided by 2 is 4, and there you go. So that is my first equation. I'm going to go ahead and graph it right now. 1, 2, 3, 4 is my y-intercept. 3 over 2 is my slope. Up 1, 2, 3 over 2. Up 1, 2, 3, 1, 2 to the right. Let's go backwards. Down 3 to the left. Down 3 to the left. Connect those dots. And there you go. We're golden. Now, next one. Let's do number 2. I got x plus 2y equals negative 8. X plus 2y equals negative 8. What do I have to do? How do I solve this bad boy? Subtract x to both sides. Very good. Go ahead and scroll up so I get a little more room here. So I'm going to have 2y equals negative x minus 8. And then divide by 2 to get y alone. Thank you. And that's going to be negative 1/2 x minus 4. That's a little sloppy. Minus 4. Because again, that 2 gets divided to that and to that. So that's my second equation, which I'm going to graph in red. So I got negative 4. 1, 2, 3, 4 is my y-intercept. Down 1 over 2. If I keep going down 1 over 2 to the right, I'm never going to intersect with the blue. So I'm going to go backwards. Up 1 over 1, 2. Up 1 over 1, 2. Up 1 over 1, 2. Connect the dots. Make your line. Lo and behold, you have this intersection point right there, which is 1, 2, 3, 4, 1, 2. Negative 4, comma, negative 2. And if I plug it into my original equations, I will make it right. I'm going to go a little bit advanced here. Not advanced, but we're not in 3rd grade anymore, so I'm going to do this in my head. Please remember that the value of x is negative 4 and the value of y is negative 2. So negative 3 times negative 4 is 12. And 2 times the negative 2 is negative 4. 12 minus 4 is 8, so it works. Second equation, x is negative 4. 2 times the negative 2 is negative 4. Negative 4 minus 4 is negative 8, so it works. And that is the solution. Does that make sense, everybody?
Yes, sir.
Does that make sense, everybody? Okay. Now, when you have a system of equations, okay, you can classify the system by the number of solutions. There are 2 main categories here. I want you to be very clear on this. There are 2 main categories here, guys. 2 main categories. You have consistent. Oh, that doesn't look good. Let's go back, change the color on that. You have consistent and you have inconsistent. Those are the 2 main groups, okay? Consistent and inconsistent. For the first main group, consistent, that means, if it's consistent, that you have at least one solution. Now, there are 2 different types of consistent systems. You can have one that's called an independent system, where you only have one solution. One solution. It is an independent, consistent. Now, dependent. A dependent has infinitely many solutions because the 2 equations represent the same line. You're going to have the same line, but sometimes they're going to alter or manipulate one of the equations to make it look different. But when you solve, they're both the same. So again, a consistent system. you're either going to have an independent system, which is one solution, or a dependent system, which is going to have infinitely many solutions. The second category is an inconsistent system. An inconsistent system has no solution because the graphs for an inconsistent system are parallel lines. That means that their slopes are the same, but y-intercepts are different. So since it is a parallel system, there are no solutions. Let's look at this graphically. How does this look as far as a graph goes? Well, if you have intersecting lines, you're going to have the main category of a consistent system. They're either going to have one solution, okay, which is independent, one solution. Or, under the same category, consistent, that means there's at least one solution. When you have coinciding lines, that means the lines are the same line, you have infinitely many solutions, and that is a dependent. And then the last, but not least, is your inconsistent. That is your main category, inconsistent. And since the lines are parallel, you have no solution. These lines are not parallel because they look pretty and they look like they don't intersect. Their slopes are equal, guys. Here's a perfect point, and here's a perfect point. So this is up 1, 2, 3, 4, 1, 2, 3, 4. Okay, 1 over 1. Here's a perfect point, and here's a perfect point. Up 1, 2, 3 over 1, 2, 3, 1 over 1. The slopes are the same, y-intercepts are different. So again, one solution, like this guy right here, that is a consistent system, but it's independent because there's one solution. When it's the same line, it is a consistent system, but they are dependent. Infinitely many solutions. And inconsistent means there's no solution, different y-intercepts, same slope, they're parallel lines. Now, if you know how to do this, you can check to see if lines are consistent or independent or dependent just by looking at them. Here are your steps. Number 1, solve for y. Put the equation in y equals mx plus b form. 2, compare the slopes and the y-intercepts. If the slopes are the same with different y-intercepts, then the lines are parallel and therefore there's no solution, and that would be an inconsistent system. If the slopes and the y-intercepts are the same, then the lines are the same line, and there are infinitely many solutions, so that means they are dependent, consistent. And if the slopes and the y-intercepts are different, not equal, then the lines are independent and there is one solution. They're independent and consistent. Because if you have one solution at least, it's consistent. Sir? Oh, you had a question. Sorry. So let's go back. Let's first solve for y here. I'm going to add 2. Well, I got 4y minus 2x equals 6. I'm going to add 2x to both sides. 4y equals 2x plus 6 divided by 4. Y equals 1/2 x plus 3/2. Now let's go ahead and solve for the second one. Let's divide 8 to both sides. Y equals 1/2 x minus 3/2. Okay, let's compare these. Are their slopes the same? Are their y-intercepts the same? No, so they have different y-intercepts and the same slope. So that means they're parallel, so that means they are... I know it's no solution, so what would it be? Independent, dependent, or inconsistent? It would be inconsistent. Very good. Next, without graphing, is the system independent, dependent, or inconsistent? Well, let's add 3x to both sides. So I got y equals 3x plus 4. And then here I'm going to subtract x to both sides. I got negative 1/3 y equals negative x plus 1. I'm going to multiply a negative 3 to both sides. So I get y equals 3x minus 3. Okay. What can you tell me about the slopes here? They're the same. Are the y-intercepts the same? So is this the same line? They're parallel, no solution, so it's inconsistent. Very good. Very good. Next. Without graphing, is the system independent, dependent, or inconsistent? Well, I'm going to subtract 2x to both sides, give me 3y equals negative 2x plus 1. Divide by 3 to both sides. So y will equal negative 2/3 x plus 1/3. And then here I'm going to subtract 4x to both sides. And y will equal negative 4x minus 3. Okay. Do they have the same slope? Are they the same line? So what is this going to be? This is going to be independent. Independent, consistent, one solution. Dependent, consistent, infinitely many solutions. Inconsistent, no solution. You guys have to memorize that. I'm sorry, there's no easy way. Are you with me? Okay. Find the solution to the system by graphing. Okay, what's my first step? Yeah, let's solve for y. Let's do this in different colors just to make sure everyone is completely clear here. So number 1, subtract x. Very good, son, because we're going to solve for y. So I'm going to subtract x. So I got negative 2y equals negative x plus 4. Now what, brother? No, just divide by negative 2. You don't want to divide by the y because you want the y to be by itself. So this is 1/2 x minus 2. Now, let's solve equation 2. Very good, son. You subtract 3x to both sides because I want to solve for y. And exactly right, that's it. Good man, brother. Now, let's graph these bad boys. Equation 1 in blue. Y-intercept is negative 2. My slope is 1/2. Up 1 over 2, up 1 over 2, up 1 over 2. Down 1 over 2, down 1 over 2. I do a lot of these because I don't know where exactly they're going to intersect. And then for number for my red one, my second equation, y-intercept is 5. 5. My slope is negative 3. So down 1, 2, 3 over 1. Down 1, 2, 3 over 1. Down 1, 2, 3 over 1. Up 1, 2, 3 over 1, just to be thorough. Bam. You get a perfect connection. That's my solution. Okay? And that's going to be 2 comma negative 1. Last but not least, we can test it. Okay? If x is 2 and y is negative 1, you got 2 plus 2, which is 4. That works. If x is 2, y is negative 1, I'm going to have 6 minus 1, which is 5. And that works. So that solution works. And you're golden. Does that make sense, everybody? Promise? Awesome.